My name's Richard. We hopefully we had a brief introduction to what we were doing by staff earlier on. So I led the subtask 1 group, and I'm going to share this session with Liesje, who led the subtask 4 group. And we basically ended up merging the 2 groups more or less. So we worked quite well together. So I'm going to take you through what we did in subtask 1. Liesje's going to take what we do in subtask 4, and then we'll hopefully kind of bring it all together at the end. Okay, so like I said, there's a quick note there. Subtask 1 in the annex wasn't a huge group. It was me and several others, but highly efficient, although very small. And subtask 4 was maybe the same, not as big as some of the other groups. So in about 2 years in, we decided it would make sense to merge some of the work we were doing. So subtask 1 looks largely at the inputs to let's call it to the HTC models or methods, and subtask 4 looks at where they go and what do we do with the outputs and who's interested in them and the stakeholder engagement. But both, in my opinion, very important parts of the entire process. So like I say, we decided to merge, and I think that was common sense. I think it was quite a strategic move, and I think we worked very well together. So you'll see them often combined. So our final report, for instance, is a combined report. What goes in and what goes out, and the remaining subtasks around the HTC and the BES validations were quite separate, but a key component of what we're all talking about. So in essence, subtask 1 was the inputs. What kind of goes in to the HTC methods, and there's a lot of things in the report about the history of the HTC and how we do it. So it's a kind of potted history of the HTC, what goes in, and the data side of things as well. And subtask 4, which Liesje will explain, was largely focused around industry engagement and making sure, really importantly, that we were doing what industry desired. So we'll open the session with that, talking about what we do at Salford. What we do at Salford is work with industry. About 50 odd percent of our work is industry funded, and the rest is academic and grant funded. So we understand the need to not do things that industry is not interested in. There's a big danger there, and a lot of academics fall into that trap. So subtask 4 was kind of hopefully made sure that we did that, and I think we did. So the final reports, as staff has suggested, and the link is in the chat, I believe, and you will certainly be able to find them, was a combined report between ST1 and ST4. So it was my section, or ST1 section, was kind of laid out in this way. It was what is the actual need for this work, and we'll talk about that in a second. A roundup of the current ways that we're looking at HTC already, and a very detailed, up-to-date review with some interesting costs and figures around how we're actually doing it at the moment. A key point is the sources of data. So what data can we put into these types of models, and the measures of measuring the outcomes to allow for comparison. So this is all about saying, okay, so the subtask 3 teams may have come up with all these different ways of doing things, and that will continue in the future, I'm quite sure. But how do we get an idea of what's good or bad for the current situation that we're in? Okay, so a house builder might have a different outlook on it than a social housing provider, or retrofit might have a different idea of what they want from this whole process. So very briefly, because staff touched on this, and probably others will touch on it in the future sessions, but and I don't want this to be a physics lesson either. What is an HTC? Heat transfer coefficient. In essence, it's the heat loss due to thermal transmission through the fabric of a building, including air infiltration, divided by the difference in temperature. It's an energy performance metric for the fabric of the building, and an overused phrase and cliche is it's the kind of mile per gallon figure for the building, which some people do or don't agree with. But in essence, we're looking at the fabric of the building, not necessarily all the time things like how efficient the boilers are and things like this. This is how the fabric reacts to energy performance. So how do we usually do it? So we've got colleagues on the call from Leeds Beckett over in the UK, and plenty of others as well who do this type of testing, and they're exceptionally good at it. It's research grade, I think it's safe to say, and it's called the coheating test. It takes around 2 weeks. We need an empty house. The costs are quite high, about €8,000, depending on who you go to and how many they do and all this type of thing. We put a lot of heating in the house, we put fans in the house, and we measure what goes on in terms of energy consumption of these heaters, and clearly the environmental conditions we measure as well. Now, there's far more to it than that, and there's far more to it than that simple equation there. But in essence, what we have now is quite a chunky test, quite expensive, but useful, very, very useful to set the benchmark for a building. And it's also safe to say that we don't do a lot of these tests. And there's some useful statistics actually in the final report, if you do read it, which I encourage you all to do, about how many of each of these types of tests have been done. So it is a useful figure. It allows buildings to be compared to the energy models, which staff was talking about. It allows us to incorporate all the different heat loss mechanisms, and it's a very good energy performance metric. Okay, now that's usually measured, like I say, by coheating, and that's at least 20 or 30 years old now, that method. There are other methods that are coming along. So these are presented here in this graph, which I'll talk about in a little while, about how we visualize these things. But this is really a slide to say that, you know, we use this method, but there's a lot more methods coming around the corner as well, and they are very well investigated, and these are all published methods as well. So these are all peer reviewed, if you like, that have gone through the process. And again, the final report gives a lot of detail on these different methods. So if you're interested in that, then I would take a look at that. But why do we need to do all this? So why am I even talking about this? Well, the reason is, like staff mentioned and Will mentioned, and I'm probably sure that someone else will mention it further down the line, is that we do have quite a well recognised and referenced performance gap globally. You know, a lot of work has been done throughout Europe and all around the globe, and this is just a snapshot of some of the studies. Now, don't read too much into this chart or this table. It's a very helicopter view, shall we say, of performance gap. But it does say that a lot of studies all around the world, it's not isolated to one type of country or one type of building, have found these gaps in performance. It's very safe to say that. And these are quite recent studies in most of that chart. So it exists. Some of the figures are quite high. You will find performance gap figures that are way higher than that in some academic reports as well. But that's just a kind of a rough idea of what the gaps might be around the EU and Canada as well. So, however, we do have luck on our side for once in building physics, in as much as we're talking about the performance gap, there's also a lot of movement around the technology that's going into homes. There are, you know, I can take my home as an example, probably not a very good one because I'm obviously more into energy than a lot of people, but I've got thermostats in each room, I've got smart meters, I've got different measuring devices, I have a weather station as well. But that's not the point. The point is that let's say normal people, the general consumer is having a lot of smart home devices and smart meters, etc., fitted in their homes. Now this figure is quite interesting here, and these are both from 2018, so we have to think that these have increased. That smart home technologies are currently present in 7.5% of homes globally, with this 44.2 million marketplace. Now that was in 2018. I'm betting that that's significantly changed. I couldn't find any more up-to-date statistics than that. And the EU is a strong leader in here. So 22.5 million smart homes, or 10% of households, with France, Germany, and the UK leading the market. So what we're saying is that the data that we're talking about here, temperature data and occupancy data and things that we use to make these calculations, isn't something that we need to start putting data loggers and things like this in. Come the day, and come the day quite soon, these devices will just be there, and we'll be able to tap the data, as we've done in recent studies, and make sense of it. And then we bring smart meters into it. So again, these are quite old statistics because the EU hasn't put this journal out again, but we see that everyone pretty much is aiming for some kind of 2020, 2025 type of completion for electric and gas. Now, clearly that might have changed because of COVID and all the things that have happened globally. But if you take again a larger overview of that, we can see that many of the EU states will have gas and electric smart meters in place for the vast majority of their buildings. So lots of data does exist, and more will be available in the future from all manners of systems. So district heating is clearly something that's being talked about a lot through the EU, and it's the same in the UK. Each home will hopefully have a heat meter in place to measure the bill and things like this. So aside from smart meters and smart thermostats, some of the more intelligent heating systems around air source and district heating and things like that will come with data. So how much data do we need? And right at the start of the annex, we needed a matrix. We needed some way of viewing all these different things. So if we look at the bubbles there, we see method 3. We've got statistical method. We've got method 4, and those bubbles basically represent the packages of data and how accurate we can get them. So the requested accuracy is on the left, and the quality of and cost of the data is going towards the right. So obviously, as we have more data, hopefully we'll get a more accurate outcome. But if we got some very, very rough data, maybe just a smart meter and one thermostat, then we can make a very low or maybe an average type of estimation. So never being satisfied, as we often are in these groups, we decided that wasn't quite doing it. So we came up with a 3D matrix, which is quite difficult to read in some places, but hopefully gets the point across. And this is dealt with in the final report. So this is a 3D metrics which allows different packages of data. So large data, small data, number of sensors in essence, and then you look at the different methods, and then we look at the expected error. And we can also do things like look at duration. So how long do we need to collect the data for, and things like that. So that is a kind of an interesting way to look at the data, I think. So over to Liesje for this next session. Then I'll probably wrap it up at the back of Liesje's session. So I'm going to stop sharing. Hopefully, Ben's.
I started sharing normally if everything's went. Okay. So I can now go into more details for the subtask 4. So there, the goal was to investigate how to go towards quality assessment, and we had following research questions. The first one was to see to what extent can the methodologies developed in the subtask 2 and 3 for which more details follow during the next presentations. How can they be used in a quality assessment framework? And a very important question, what is our target group? Are there government, certification bodies, social housing, energy service companies, maybe building owners or constructors? Who is interested in such assessment, and what do they exactly want then? And then also, what are the necessary boundary conditions? Of course, reliability and accuracy is important, but normally the cost can be too high. So we have to search for a balance for that. So what are the necessary boundary conditions for the target groups? To do that, we did an online survey between January and December 2019 with the main focus on a measured HTC. This was done in several languages, and all 243 responses from the 14 European countries were translated to English for analysis. I will shortly present the outcomes. All the results are published in the reports you can download, and also in a journal paper with free access. I can show it here. The first aspect we studied in the survey is where the participants came from. You see here the country of origin of the various stakeholders that participated. The main participants came from Switzerland and Belgium. When we have a look at the professions of the various stakeholders in the survey, you see a wide variety with mainly engineers, architects, building contractors, energy service companies, and also certification bodies. The scope of the building types operated by these stakeholders is also covering all building types. So you see non-residential buildings, single-family buildings, multi-family buildings, and most of the participants, they cover all building types. When we have a look at the first figure here, the results show a good level of trust in the reliability of existing methods to calculate the energy performance of buildings. You see that over 75% of participants think that the calculated energy performance is reliable. Despite this level of trust, however, you also see that more than 90% of the stakeholders are still interested in a method that can measure the actual energy performance. So this indicates that there is a good opportunity to introduce a reliable method based on measurements. We also asked whether they think that their customers would be interested in such a method, and also over 80% of participants thought they would. We asked in more detail about their motivation of their interest. So first you see the answers of the interested stakeholders. You see here some of the most popular answers. So for example, it would be possible to have certification based on the measured HTC. The building constructors would be able to differentiate from competitors. There can be quality assurance and validation. It can imply administrative simplification. It can be used in fault detection. It can be beneficial for defining retrofit measures. User influence could be determined, and the performance gap can be identified. Then here you see the motivation of the non-interested stakeholders. Also some of the answers. There is no time and budget to do this. The HTC is too technical or too theoretical, and also not a real value. Another one said that there are only few quality problems related to the building envelope, and the impact of the technical system can be considered as more important. So maybe we should more look into that. It's not relevant in the design phase. This is only necessary when there are disputes. There are already some good tools and approaches available, such as thermography, and pinpointing the causes of the higher energy consumption would be more interesting. We then asked for potential services they could provide to their clients, and we grouped them into 6 categories. These responses seem to demonstrate a desire from the stakeholders to create a feedback loop to improve the build quality, both for existing projects as for future projects. And we see that most of the people answered with design and retrofit guidance or quality assurance. Interestingly, there was relatively little interest in the answer building energy classification, which you see here. Only 8% of the responses, which seems an obvious use for such measurements though. Perhaps this reflects that HTC measurement methods are still rather new to the industry, and that there is still progress to be made to validate them, to make them more known, and then maybe they can, or we can move to more legislative tools for such measurements. We also raised some questions on the boundary conditions. The first question we asked was about the timing when the test should be carried out. It was frequently mentioned that the testing should be done before or shortly after delivery. Because then defects could be found and remedied while the project was still under warranty and the builder was still closely involved. On the other hand, many respondents answered that it might be better to do it within some time after the delivery, because the measurement could not accurately be undertaken soon after the completion, because there could be drying of components at this time, and that might be affect the result of the measurements. Respondents also highlighted that performance measurement could play an important part during building retrofits, and that measurements could also be an ongoing process, so that it it's not only needed to do it right before or right after delivery or after, for example, 1 year, but that it can be an ongoing process during the building phase. The next question was about costs. 100 till 500 euros was here the most popular answer. And it is also in line with the current cost of, for example, an air tightness measurement. And this kind of measurements is by far the most common performance measurement currently in use. The range of responses, with 30% indicating that a cost of over 500 euro would be acceptable, show that many stakeholders would find the cost slightly higher than that of an air tightness measurement also acceptable. For example, an co-heating test would be certainly be above 2,000 or 5,000 euros. That cost would be too high for most participants in the stakeholder group. And also an popular or an answer that we found very often in this survey was that the cost is also dependent upon the size and complexity of the building, and it's very hard to really say that cost is acceptable for us. When we have a look at the acceptable duration of such a performance measurement, the majority felt that it must be a few days long at most. But several respondents also highlighted that they did not believe that an accurate result could be generated in only a few days. And some others answered that if the test was not invasive, then the length of the test wasn't significant, and also it can be or it can have longer duration, or can also be an ongoing monitoring process. And it's also illustrated in this answer. So given that the tests are no invasive, I don't see a reason why the duration matters. Then we also asked for the acceptable confidence interval. And there you see that the most popular answer is an error between 5 and 10%. But we also know that this is very challenging, giving similar uncertainty tests, but then even then this answer might also be very important to illustrate, as someone answered that if the error margins become very large, it will be of little use to use measured data rather than calculated values that already exist. So the accuracy of the method seems also matter a lot for the stakeholders. Then some small concerns before I can turn again to Richard for the conclusions. We also asked the stakeholders for some concerns they have. We see that they have a lot of complications in mind. They are from scientific issues such as weather influence, heat gains, inhabitants, over practical ones, just as accessibility of the building, the duration, the costs, also damages to the building. They can also be logistical, such as timing, even theft is mentioned, availability of electricity, and they can also be related to the results of the analysis, such as missing data, consequences of bad results, bias towards excessively good results, and so on.
So thanks for that, Liesje. It's good to see what a lot of people thought about what we're doing, and hopefully there was some positives in there as well as some issues to overcome. So our main findings. So again, you know, there's a lot more in the final report, so do take a look at it. But we find that in general, there's a lot more onboard data. So when we talk about onboard data, we're talking about when we don't have to fit extra things into the building. So whether that's smart thermostats, air source heat pumps with digital connections, smart meters, clearly, that we're finding a lot more of this, and we think that that trend is, you know, set to develop at a very, very great pace. The current in situ measurement methods that we're using are rapidly improving, and we shouldn't forget about them. That they take less time, they're more cost effective than ever before, and that might be a developing market as well. And it may come that we combine some of these methods as well. The smart meter rollout is advanced in most countries, and again, we don't see any reason why that won't continue. As Liesje said, that we think there is a strong demand for this type of measurement, and when we come to the crunch here, which is about reaching carbon zero and things like this without any risk, we think that the measurement of buildings is very important. Costs should be kept low, as Liesje's charts showed, whilst accuracy should be as high as possible. They're kind of two countering points there, but we should try our best to hit those targets. It's said by many, and it's highlighted in our report, that if we're using these for verification or validation or measurement that's important to reach zero carbon in buildings, or successful retrofits, whatever we're using them for, we feel there should be some validation mechanisms or methods put in place, whether that's a pool of data that people can use to test their methods, whether it's test houses or test homes. We feel that whenever we get lots of different methods, we need to see if they work, and we need to see if they work accurately, how long they take, and all the other metrics that we've discussed along this presentation. HTC may not be the best metric to use. It doesn't mean anything to anyone. You can have a high HTC for a building just simply because it's very big. So do we talk about putting meter squared or meter cube? Again, there's some interesting points raised in the final report about normalization of this data, making it weighted in essence. The real crunch to all this is that we may have a very good HTC method or estimation, and we may even get to the point where it's perfect, whatever perfect means. But unless we have somewhere to put this figure and for it to have a home, either in the energy performance certificates, the EPBD documentation, then we're kind of not making any progress. So we need some policy shifting to allow us to use this figure, this as measured figure, whatever it turns out to be and what a method it turns out to be. I think it's been mentioned certainly in the meetings that we've had recently that a pan-EU or global validation process should be developed. There shouldn't be any reason why the methods that Liesje's using out in Belgium should be any different than the methods that I'm using in Salford or that Leeds are using or Loughborough are using. We think that we should be able to reach a point now where we are able to measure a home's HTC with a validated method. We will obviously continue this work, but I think the final report closes with the encouraging of a formal process of validation to be worked on and some policy movements around real world performance. Otherwise, the 5 or 6 years that we've been doing this could be deemed as not ever so useful, even though we've got methods that are clearly very advanced and very well performing.